Assalamu alaikum students, welcome to today's lecture on salts. In this session, we will cover the uh, long question number 4 to 5 of the unit salts and finally the think tank questions. Each question will help you to build up from basic recall to deep understanding and application of concepts. So let's begin. Question number 4 is explain why ionic compounds have lattice structure and how this influences their physical properties. Ionic compounds का वो जो lattice structure हमने पढ़ा है वो कैसे बनता है और ये कैसे उनकी physical properties को करता है affect करता है influence करता है. Ionic compounds form lattice structure due to the strong electrostatic attraction between oppositely charged ions, creating a giant repeating pattern of ions. This structure influences physical properties like hardness, brittleness, high melting and boiling point, and electrical conductivity. Basically, जो अपोजिट चार्ज होते हैं, एक पॉजिटिव चार्ज के सराउंडिंग में सारे नेगेटिव चार्ज इकट्ठे हो जाते हैं और एक नेगेटिव चार्ज के सराउंडिंग में सारे पॉजिटिव चार्ज इकट्ठे हो जाते हैं. इस तरह से एक रिपीटेड पैटर्न ऑफ आयंस बनता है और एक जिएंट स्ट्रक्चर क्रिएट करता है. अब ये स्ट्रक्चर क्योंकि फोर्स ऑफ अट्रैक्शन इतनी इनके बीच में स्ट्रांग होती है अपोजिटरी चार्ज आयंस के बीच में कि इन्फ्लुएंस करता है हार्डनेस के, वो मटेरियल बहुत हार्ड होता है और उसमें शाइन होती है, ब्रिटलनेस होती है और उसका बॉइलिंग एंड मेल्टिंग पॉइंट हाई होता है और इसके साथ साथ वो इलेक्ट्रिसिटी भी कंडक्ट करता है. मजीद हम इसको इलेबोरेट करेंगे. लैटिस स्ट्रक्चर formation in ionic compounds, atoms transfer electron to form ions, anions and cations. These oppositely charged ions are strongly attracted to each other, leading to the formation of a highly ordered three-dimensional structure called a crystal lattice. This lattice is giant, meaning it extends throughout the entire sample and contains a vast number of ions influence on physical properties जैसे कि hardness and brittleness. The strong electrostatic forces within the lattice make ionic compounds hard, meaning they are resistant to deformation or scratching. However, they are also brittle, meaning they can easily shatter when subjected to stress. This is because if one layer of ions is shifted, the lattice is disrupted. वो brittleness होते हैं उनमें, वो उनके ऊपर कोई भी प्रेशर है तो वो बिखर सकते हैं. क्यों? क्योंकि अगर एक लेयर ऑफ आयंस शिफ्ट हो तो पूरा जो स्ट्रक्चर है वो डिसरप्ट हो जाता है. एंड द सेम चार्ज आयंस विल रिपेल ईच अदर कॉजिंग द कंपाउंड टू ब्रेक. उसमें क्या होगा कि बीच में से एक लेयर ऑफ आयंस अगर शिफ्ट हो जाए, फॉर एग्जांपल नेगेटिव चार्जेस बीच में से सेंटर में से हट जाए लेयर, तो सारे जो पॉजिटिव चार्ज एक दूसरे के सामने आ जाएंगे, वो एक दूसरे को रिपेल करेंगे. इस तरह से जो कंपाउंड होगा वो ब्रेक हो जाएगा. Melting and boiling points. The strong electrostatic forces between ions require a large amount of energy to overcome, resulting in high melting and boiling points. उनके बीच में इलेक्ट्रोस्टैटिक फोर्सेस इतनी स्ट्रांग होती हैं कि उनको ब्रेक करने के लिए बहुत ज़्यादा हाई मेल्टिंग एंड बॉइलिंग पॉइंट रिक्वायर्ड होता है. Okay, next is electrical conductivity. In the solid state, ions are fixed in the lattice and cannot move freely. So ionic compounds are poor conductors of electricity. However, when molten or dissolved in water, the ions are free to move and can conduct electricity. Solubility. Ionic compounds are generally soluble in porous solvent like water because the water molecules can interact with the ions, disrupting the lattice and dissolving the compounds. Next, question number 5 is describe the preparation, separation and purification of salts using an excess of insoluble carbonate, providing an example reaction. Preparation, separation and purification of soluble salts by reaction of an acid with excess insoluble carbonate. हम कैल्शियम कार्बोनेट को हाइड्रोजन HCl के साथ रिएक्ट करेंगे तो we will get calcium chloride and carbon dioxide and water. Preparation. An acid reacts with an excess of insoluble carbonate to form a soluble salt, carbon dioxide, gas and water. The excess carbonate ensures that all acid is neutralized in the reaction. Separation. The resulting mixture contains soluble salt along with carbon dioxide gas and water. The salt can be separated from the mixture by techniques such as filtration or decantation. Okay, next is purification. The purified salt can be obtained by further washing the solid product to remove any traces of insoluble carbonate. The preparation, separation, and purification of soluble salts by the reaction of an acid with different substances involves specific procedures tailored to each reactant to ensure the formation of pure soluble salts. Now let's start the think tank section. Question number 1. Design an experiment to make magnesium sulfate crystal with suitable reactants. We have to make the magnesium sulfate crystals, and for this purpose our main object is to synthesize magnesium sulfate crystals through a reaction between magnesium oxide and sulfuric acid followed by crystallization. Here are few reactants like magnesium oxide and dilute sulfuric acid, and equipments are beaker, stirring rod, heat source, for example hot plate or burner, filter paper and funnel, evaporating dish. Procedure: add a small amount of magnesium oxide from like 2 gram to a beaker. Slowly pour dilute sulfuric acid, which is 20 ml of 1 molar H2SO4 into the beaker while stirring until the reaction completes. No more fizzing or excess magnesium oxide remains. Okay, then filter the solution to remove any unreacted solids. Transfer the filtrate to an evaporating dish and gently heat to evaporate some water, concentrating the solution. Allow the concentrated solution to cool down slowly at room temperature to form magnesium sulfate crystals. Collect and dry the crystals. There is an exothermic reaction like magnesium oxide plus H2SO4. They are giving magnesium sulfate and water. Safety: wear gloves, goggles, and work in a well-ventilated area due to acid use. Because in this experiment we are dealing with acid. Okay, question number 2 is design an experiment to make potassium sulfate crystals using titration method. Now we have to make potassium sulfate crystals by the using the procedure titration. To prepare potassium sulfate crystals using the titration method, follow these steps. Material: potassium hydroxide solution, known concentration. Sulfuric acid solution, which again known concentration. ठीक है. phenolphthalein indicator जो हम यूज करते हैं ये ऑप्शनल होता है. Then distilled water. Required materials are distilled water, burette, pipette, conical flask, and evaporating dishes. Procedure: titration. Fill the burette with sulfuric acid. Pipette 25 ml of potassium hydroxide solution into a conical flask. Add a few drops of phenolphthalein to the conical flask. Slowly add sulfuric acid from the burette to potassium hydroxide solution until the pink color disappears, indicating neutralization. Note the volume of sulfuric acid used. Okay, then reaction to form potassium sulfate. The reaction between potassium hydroxide and hydrogen H2SO4 form potassium sulfate in solution. 2 KOH and H2SO4 hydrogen sulfate, they will react and give the potassium sulfate and water. Evaporation to crystallize. Pour the neutralized solution into an evaporating dish. Heat gently to evaporate water, leaving potassium sulfate crystals. Collection: allow the crystals to cool and then filter and dry them to obtain pure potassium sulfate. Next question is, name 2 types of salts that are always soluble. First is sodium salts, then nitrate salts. Sodium salts are soluble because sodium ions have single positive charge and a large size. Low charge density weakens the ionic bonds in the lattice. Water molecules hydrate that sodium positive charge easily, releasing enough energy. This overcomes the lattice energy, so all the sodium salts are dissolved. ठीक है. नाइट्रेट सॉल्ट्स कैसे soluble होते हैं? नाइट्रेट आयंस is large with one charge spread over 3 oxygen atoms. Oxygen ions. Delocalized charge reduces lattice energy in the solid. water hydrogen bonds with nitrate, stabilizing it in solution. Hydration energy beats lattice energy, making all nitrate salts soluble. Question number 4 is, how could you prepare pure dry sample of copper sulfate from copper carbonate? To prepare a pure dry sample of copper sulfate from a copper carbonate, you can use a straightforward method involving a reaction with sulfuric acid followed by crystallization. Here a concise step-by-step procedure. React copper carbonate with sulfuric acid. Add excess copper carbonate powder to a beaker containing dilute sulfuric acid, which is 1 mole of H2SO4 sulfuric acid. Stir gently. The reaction is if calcium copper carbonate is reacting with sulfuric acid, it will give copper sulfate and water and carbon dioxide gas. You will see fizzing as carbon dioxide gas escapes. Keep adding copper carbonate until no more fizzing appears, ensuring all acids is neutralized. Filter the mixture. Filter the solution using filter paper and a funnel to remove excess solid copper carbonate. The filtrate will be clear blue solution of copper sulfate. Evaporate the solution. Pour the filtrate into an evaporating dish and heat gently. To evaporate some water, stop when the solution becomes saturated. Crystals start forming at the edges. Crystallize. Let the saturated solution cool slowly at room temperature. Copper sulfate crystals will form as the solubility decreases. Dry the crystals. Decant the required liquid, collect the crystals and dry them by pressing between filter paper or leave them in a low temperature oven to avoid losing water of crystallization. Question number 5. What would you add to dilute sulfuric acid to make copper sulfate? To make copper sulfate from dilute sulfuric acid, you would add copper oxide to copper metal. Copper oxide method. When copper oxide is added to dilute sulfuric acid, it reacts to form copper sulfate and water. Copper oxide will react with sulfuric acid and will make copper sulfate and water. Copper metal method. If copper metal is used, it reacts with dilute sulfuric acid to form copper sulfate and hydrogen gas. If we use if copper react with hydrogen sulfate, the copper metal react with sulfuric acid, it will give copper sulfate and hydrogen. After the reaction, the copper sulfate can be obtained by evaporating the solution, leaving the crystals of copper sulfate. So thanks for watching. Today we have completed all sections from the chapter on salts. By revising all these 4 sections, you now have a complete understanding from basic facts to advanced application. If you like this video, then like it, comment down, share with your friends and subscribe to this channel. Keep revising, keep practicing, and inshallah you will perform brilliantly in your exam. See you in next lecture. Till then, Allah Hafiz.